Hello everyone, welcome back to a second video continuing on quadratic functions. And in our last video, we didn't do too much with equations. We mainly just looked at some graphs and we focused on analyzing. We focused on finding the vertex, the axis of symmetry, if a graph opens up or down, if that vertex is a maximum or a minimum, and what the domain and range were. What we're going to be doing in this video is we're going to be using our previous knowledge of translations back from last unit when we identified if a function was moving left or right or up or down. And we're going to be using those translations to tell what the vertex of a quadratic function is and analyze it without actually having the graph in front of us. So that's our objective for this video. And to start, we need to really make sure we remember our basic translations from last unit. And the key here was if a number was being added or subtracted, and if a number was inside or outside of the parentheses. Hopefully you remember, but if not, here's a good refresher. If we have a number being added outside of the parentheses, that is a shift up. If we have a number subtracted, but it's still outside of the parentheses, that's a shift down. And then our inside of the parentheses numbers are going to move us left or right. And remember, that's the tricky one. It's the opposite of what we'd expect. So if I see f of x minus 17, that's actually a shift going right. And if I see f of x plus 17, that's a shift going left. So very important today that we remember our left, right, up, and down shifts. Now, for what we're doing today, when we get to the very end, we'll be doing a 4-step process to analyze a quadratic function in this thing we're going to call vertex form. Now, steps 1 and 2 are tied together. We're going to look at our equation and we're going to identify what the translations are. We're going to determine if it's left and up, or if it's right and up, or right and down. And then in step 2, we're going to find the new vertex using 0, 0 as our starting point. We'll see how that works in a second. In step 3, we'll have to determine if the graph is opening up or down, looking at the number at the very front. And then we'll draw a quick sketch, not a very accurate one, but enough to analyze, which is what we'll be doing in step 4. So to begin, we're going to start by looking at a couple equations and identifying the translations in the vertex, and then telling if it opens up or down. So we'll start with these first two. Now, to determine the translations, I'm always going to look at what's going on inside the parentheses and also what's being added or subtracted at the end. Now, I see that x minus 5 in parentheses. That's telling me that this function is being moved right 5. And the plus 7 at the end is telling me this function is being shifted up 7. Now, what that's going to do is that's going to tell us what our vertex is. Okay. We always think of a starting point of 0, 0. If you think back to our first quadratic video, the vertex of that original function, the green one, was 0, 0. So if I start at 0, 0 and I go right 5 and up 7, then that's going to give me the point 5, 7. Now, some people will want to sketch this out just to help them visualize. Starting at 0, 0, which is the origin, if I go right 5 and up 7, then the point here would be 5, 7. Now, there is a shortcut for getting that vertex, but I'm going to let you discover that on your own. So that is our vertex for this one. And we also are being asked to tell if this graph opens up or down. And the way we tell that is by looking at the number out in the front. And all we need to look at there is if that is positive or negative. Because one of the things we learned last unit is that a negative number out front is going to flip this graph upside down. But that's a positive. So based on that, this graph is going to open up. If that had been negative, it would have opened down. But our vertex is 5, 7. And it opens up. For now, that's all we're doing. That might be a little hard at first, so let's take a look at another one. We have y equals -3 times x plus 1 squared plus 10. Again, we will start with our inside the parentheses and after the parentheses first. Adding inside the parentheses gives me a shift left 1. Plus 10 outside gives me a shift up 10. If I start at 0, 0 and go left and up, then that's going to give me a vertex of -1, 10. Again, if you need the visual, we're starting at the origin, going left 1, and all the way up to 10. And that point would be -1, 10. In terms of does this one open up or down, we'll take a look at the a value over here. This time, that number out front is negative. What that means is that this graph was flipped upside down, and that means that this one, because it's negative, opens down. Okay. Now we've got a couple more here. If you feel like you've got the idea so far, go ahead and give these two a shot. If you are not sure, stay on and hear the explanation for the next one. We've got x minus 11 squared minus 9. I look at what's inside the parentheses and after. A subtraction inside means I'm going right. And the subtraction outside means we're going down. Right 11, down 9 is going to put me down below. That vertex will be 11, -9. And do I see a negative out front? I do not. Based on that, this one opens up. Likewise with the last one, we'll look inside the parentheses and after. That plus on the inside means we're moving left 2. The plus 3 means we're going up 3. And if I move left 2 and up 3 again from the origin, that'll put us at -2, 3. Hopefully a few of you are starting to see the shortcut that you can use to go straight from the equation to that vertex. And in terms of opening up and opening down, I don't see a negative on this one either. It's a positive 0.25. Therefore, this one will still be opening up. Now, for the analysis itself, we've basically done everything we need to finish this problem out, and we're going to start by looking at our last example, which is y equals 0.25 times x plus 2 squared plus 3. Now, if we've done these translations, if we've done everything else, we've already recognized that the vertex is -2, 3. We've already found out that this parabola opens up. And we should know from our last video, the axis of symmetry is always x equals, and we just take the x value from the vertex. One of the other things we know for free is that the domain here will be all real numbers. Sorry, that was notation that I use in another one of my classes. So that's all reals. We also know if this parabola is opening up, then the vertex must be a minimum. Remember, opening up is a U shape. Now, the only tricky thing here would be the range, but this is how we're going to figure that out without really making an in-depth graph. I'm going to draw a quick sketch. This was step 4 in my list from earlier. My vertex is -2, 3, and we know that this graph opens up. So all I need to do is draw an opening up graph that passes through -2, 3 as the vertex. Based on that, I should be able to find my range. I know it's the y value, so I know it has to involve the 3. But I'm looking at that graph and I ask myself, is the graph above 3 or is it below 3? And it's definitely above. And therefore, our range should be y is greater than or equal to 3. Now, I haven't made an amazingly beautiful graph here, but I've done enough to identify these key features. So again, identify the translations in the vertex, determine if the graph is going to open up or down, and you should be good to sketch and analyze from there. Now, we'll cover this in class a little bit as well, so if this isn't entirely perfect, don't be too hard on yourself. But we will do one more of these together. So we've got y equals -3 times x minus 2 squared plus 4. And I'm going to start all the way back with step 1. I need to identify my translations. So I look inside, and I look at the back end, and that -2 inside is moving me right, and the plus 4 is moving me up 4. So based on that, right 2 and up 4 would give me a vertex of 2, 4. Since we're graphing anyway, I may as well show going right 2 and up 4. That's my vertex there. My axis of symmetry is easy from that. X equals 2. Now I definitely want to know if this graph is going to open up or down. I need to look at the value out in the front. And look what we have there. That value is actually negative. What's that going to tell me? Well, that tells me that this graph is going to open down. And if it opens down, I'll actually go ahead and sketch it now. Then I know that that vertex is going to be a maximum or a high point. Remember, those two things are always connected. My domain is actually always easy because that is just all reals. And we finish with the range involving that y value. We know that the 4 from the vertex will be involved. And if I look at my graph, because it opens down, I am below 4. Since the graph is below, I will use a less than or equal to sign. And that is how we graph and analyze a quadratic in vertex form. You may want to watch this video a second time just to get a little more rhythm on the process. Otherwise, we will be covering this a little bit more in class in our first session of the week. Thanks for watching.